Students. So today's session was about fuzzy logic, and we discussed an example, a simple example of how to control fan speed when we have the input temperature. So as you can see on the screen, I have defined the objective of this example for your understanding. So it is to design a fuzzy logic controller that determines the appropriate fan speed based on room temperature. System should mimic human reasoning. That is the purpose of fuzzy logic. And here, temperature is described using linguistic terms such as cold, warm, and hot. Fan speed is described as slow, medium, or fast. And instead of using rigid threshold values, the controller should allow partial membership in multiple temperature categories, enabling smoother control of the fan speed. So we have input variable is temperature and its range is from 0 degrees Celsius to 40 degrees Celsius. Output variable is fan speed and it is ranging from 0 to 100. That is percentage. So fan speed percentage of maximum speed. Now this is the standard library list. The main thing to note is that for fuzzy logic to be executed in Python, we need to install and import scikit fuzzy. This we discussed in the session in the morning, right? So let's again elaborate on the problem statement. So we have input variable is temperature, which has three fuzzy sets, cold, warm, and hot, and these are the values. Okay, so let me write these values in our whiteboard, a blackboard. So we have cold is having 0, 0, and 20. So in any membership set, we have three values defined. Okay, we are talking about a triangular membership function. So we have these three values defined, wherein A is nothing but it represents start of the triangle. Okay, and B is peak value in that particular membership. So membership value is equal to 1 at this value of input B. So this A, B, C are input X values, X axis, and membership values are defined on the Y axis from 0 to 1 or 0 to 100%. And C is end of triangle for that particular membership. So now when I'm saying cold is 0, 0, 20, if I plot the graph, okay, x-axis is temperature, y-axis is the membership level, okay. The maximum level is 1, minimum level is 0 for membership, and this is from 0 to 40 as per our understanding of the question. Let me just see it again. Okay, temperature is 0 to 40, and 0, 0, 20 means at 0 the value of cold membership is maximum because the second value B, okay, peak, and at 20 it is 0. So I'll define the 20 point on the x-axis. This is say 10. One second, I just change the color. Yeah, this is 10, this is 20, this is 30, this is 40. Okay, degree Celsius. Now this line is going from 0 to 20. That's it. This is the cold membership line. Okay, so anything less than 0 is also to be considered as 0. Okay, now similarly, we have warm membership is as per our example 10, 20, 30. 10, I just write it on the board. So 10, 20, 30. So 10, it is starting at 10, it is ending at 30, and 20 is the peak value. So let me mark this with this color itself here. So it will look something like this. This is for warm. And similarly, hot, we have starting from 20, peak value at 40, and final is also 40 because that is the end. So hot can be shown by different color. Let us say we are showing it by this color. So at 40, it's going like this. Okay, these are the three levels. For understanding purpose, I will write it here above the values also, A, B, and C. Now, why were we getting the calculation wrong? And the input temperature was 28 degrees Celsius. So input temperature we took as 28 degrees Celsius. Now, if I see what is the membership level in the cold membership side, we know that 28 is nowhere in the cold membership line if you see the graph. Okay, so 28 is somewhere around here, right? Now that means cold membership mu of cold will be 0 for 28. Mu of cold and for x is 28 here. So it is input value, it is 0. Similarly, if I calculate mu of warm, now I need to know that 28 is lying on which side? On the rising side of the warm membership or on the falling side? It is lying on the falling side, right? It is lying on the falling side. And for the falling side, the value of the membership is having a different formula than when the point lies on the rising side. So if it is on the rising side, let us say it is x minus a upon b minus a. Okay, you know what is a and b here. Okay, this is on the rising side. If it is on the rising side, which is not in this case, and for the falling side, mu of x is equal to c minus x upon c minus b if the point or the input is on the falling side of the line. Here for t equal to 28 and in the warm membership, it is on the falling side of this line, right? So therefore, the value to be calculated is, sorry, I just change the color for clarity. Yeah, is equal to falling side is c minus x. C is what? If you see in the warm side, A, B, C, C is 30 minus x is 28 or t is 28 in this case. I'll just replace this also by x so that we don't have confusion. Okay, divided by b minus a. This is b, this is a. B is 20 and a is 10. Okay, right? Oh, sorry. My mistake again. C minus x upon c minus b. Sorry, c minus b. 30 minus 20. So this is 2 upon 10, which is 0.2. And for calculating the hot membership, now from the hot line, it is on the rising side. 28 is on the rising side of that line, if you see the hot. So rising side, you have the formula x minus a. X is nothing but 28 minus a. For the hot, a is 20. And upon b minus a, b is 40, a is 20. So that's how it comes out to be 8 upon 20, which is 0.4. So this value we were not getting because of the calculation mistake we were doing. So again, I repeat, this is the rising side of hot membership. And for that, x minus a upon b minus a will apply. So x is 28, a for the hot membership, this is a, this is b, this is c. A is 20, b is 40. So if I replace x minus a, it's 28 minus 20, b minus a, 40 minus 20. So it is 0.4. So at t equal or x equal 28 degrees Celsius, the membership related with warm category is 0.2 and that is 20% and hot is 40%. So we can say in our general language that it is this temperature be considered to be 20% warm and 40% hot. Okay. Now this step we call it as fuzzification. This step. Okay. So we can say 28 degrees Celsius is 20% warm and 40% hot, as per our understanding of this example. Now the next step is rule firing strengths. So let's visit the Python file again and understand what are the rules. Rules are nothing but we defined if temperature is cold, then fan speed is slow. If temperature is warm, then fan speed is medium. If temperature is hot, then fan speed is fast. Right? So accordingly, now each rule we use it to uh, fire according to the membership of the condition. So rule one, it was if temperature is cold, fan speed is slow. So cold membership is zero, right? Value at 28 degrees Celsius. So therefore, rule one strength when we apply, it will be zero. Okay. Now similarly, rule two was if temperature is warm, fan speed is medium. Now, what is the strength of rule two? We know that 28 degrees Celsius is considered as zero point 0.2 warm or 20% warm, right? So strength of rule 2 is nothing but can be understood as zero point 0.2. And similarly, rule 3, which is nothing but hot condition. So rule 3 says if temperature is hot, fan speed is fast. So since hot membership is zero point 0.4, rule 3 strength is zero point 0.4. So we got these three rule strengths. Now when we associate with the output, we have this is the rule, this is the output set, which is the fan speed in terms of percentage, and its strength we can associate based on these rule strengths. So rule 1, which was nothing but fan speed is low, of course when it's cold condition, its strength is 0. And rule 2, fan speed is medium when temperature is warm, its strength is zero point 0.2. And rule 3, when fan speed is fast when it is hot, so its strength is 0.4. So we have mapped these rule strengths with the output set. Okay, now as we can see in the graph of the membership functions of the output, we can clip the graph at the appropriate level. What do I mean is that if I go to the uh, fan membership functions, this one, so if you see here, the medium triangle, okay, it needs to be clipped at zero point 0.2 because the membership rule strength for this second rule is zero point 0.2. Similarly, the slow triangle, obviously it is to be clipped at 0, and the uh, last triangle is clipped at zero point 0.4, right? So that is what if you can see here, I'll just share the output. Yeah, see. So the clipping is shown here clearly. Okay, this is the clipping, right? The cold one is clipped at 0, medium cold or fan speed slow is at 0, medium is clipped at zero point 0.2, and fast is clipped at zero point 0.4. Understand? Now we will see the output membership function. As you can see in the graph, it is clipped at zero point 0.2, not at 20 degrees Celsius, the medium region, but at a point which is, if you see, slightly away from 20, or if I can see, it might be exactly 30. So we will discuss what is that particular temperature also. Okay. So that is the next step. So it is now equation of membership functions, output membership functions, right? Similar to input membership functions, output membership functions. Okay. Now we have only two categories. Slow is not there here. So medium, let us say the triangle. Now, what was the limits for medium speed as per the question? If you see, we defined it as, if you see here, the question, original question. So 25, 50, 75. Okay. And for fast, it is 50, 100, 100. These are the two categories we need to focus on. So 25, 50, 75. So medium is having a membership set 25, 50, 75. and understand in terms of A, B, and C so that we don't get confused again. A, B, and C. Okay. Now, if you see the graph of medium, I'm only drawing medium. So it is starting at 25, attaining the peak value at 50, and again going down at 0. Sorry, 75. So let us say this graph looks something like this for medium, right? Now, value of any variable x for this medium category is similarly, it can be understood. It is 0 if obviously the x value or speed value is less than 25, obviously. And between 25 to 50, this one peak value, it is a rising graph. So if I'm saying rising graph, so what is the value? It is x minus a upon b minus a. I'll write it here for your clarity. X minus a upon b minus a, and that value in this case is x minus 25 upon b is 50. 50 minus 25 is 25. Okay. Similarly, for the next category where it is falling, the between 50 and 75, the value as per our understanding on the falling side of the graph is c minus x upon c minus b. Okay, so if I write that here, c is nothing but, I'll write the interval first so that we have clarity. 50 less than or equal to x less than 75, right? Now c is 75 here, so 75 minus x upon c minus b is 75 minus 50. Okay, and finally when it is x is greater than 75, it is 0, right? For the medium category, it is 0 here, it is 0 here. Okay, so this is the membership for medium category in this case. Now when we are clipping at 0.2 for the medium category, what does that imply? So clip at 0.2 means now the modified membership, which I'll write it as mu dash of medium x, is nothing but minimum value of the original mu medium of x and 0.2, because upper limit is 0.2, clipping at 0.2 means. Now if you see for the category 25 to 50, let us say start with 25. 25 minus 25 is 0, so 0 upon this is 0, so minimum of 0 and 0.2 is 0, and that is why if you see the graph here, the output graph, so at 25 it is 0 only, if you see here. Okay, and similarly if I just do trial and error, when it is 30, x is 30, so 30 minus 25 is 5 upon denominator is 25. 5 upon 25 is 0.2, so minimum of 0.2 and 0.2 is nothing but 0.2 only. So at 30 degrees Celsius we are having this line, 0.2 line. Okay, right? And then the clipping starts for all other values, anything greater than 30 and less than 50, we'll have the mu medium of x is greater than 0.2, and minimum of those two values will always be 0.2. Okay, so I can write this as is equal to 0.2 for all x. I'll write it like this: for 30 less than or equal to x less than or equal to 50. Okay, for the second category I'm talking about. Now for the fast fan speed, we have, for the fast fan speed, uh, and before that, if you see in the third category also, for the medium, the third category also, if you take any value between 50 and 75, it is either 0.2, okay, which is the minimum value. Okay, if I let us say I take 50, we already took 75 minus 50 is how much? 25 upon 25 is 1. So minimum of 1 and point 0.2 is obviously point 0.2. And the other end, when the temperature is 75, so 75 minus 75 is 0. So 0 upon this is 0. So if I see the graph on the other side, so it is not going up to 75. It's stopped in between because it's merging with the clipping of hot category. Otherwise, that would have been 0. Okay. So at 60, if I calculate this, so 75 minus 60 is 15 upon 25. 3 upon 5 is zero point 0.6, which is greater than zero point 0.2. So it will be zero point 0.2 only. So I'll also write, instead of 50, I can put it at 60, because after 60, it is merging with the hot category, as you can see here. Okay. Now, the clipping similarly of the hot category, we will see, which is the not hot category, sorry, fan speed maximum. This is the output we are talking about. So, which is fast is the category. Medium was the category we discussed, fast. And if you see the fast, the values are 50, 100, and 100. Okay, as per our given conditions. Here, I will just show it to you. 50, 100, and 100 for fast category. And therefore, for the membership of fast of any variable x is nothing but, we can again define the intervals. Either it is 0 when x less than 50, or it is now on the, if I see the graph of fast, it is after 50, it is simply rising, right? And maximum value is, say, let us say 100, and after that it is going like this. So this is a rising graph only. So rising graph value, we discussed x minus a upon b minus a. So x minus a is x minus a is 50 upon b is 100 minus 50 for 50 less than equal to x less than or equal to maximum value 100. These are the two values. And because it is clipped at 0.4, the fast category, so we have the modified membership value for fast is nothing but minimum of, okay, the original membership value and 0.4. Okay, so let us say at the maximum value 100, 100 minus 50 is a numerator, which is 50 upon 51. So minimum of 1 and zero point 0.4 is zero point 0.4, so at 100. So where is it exactly? So if it is 75, 75 minus 50 is 25 upon 50, which is half. Again, it's 0.5. 0.5 is greater than zero point 0.4, so minimum will be 0.4. Let us say if I'm talking about 70 as the fan speed x value, so 70 minus 50, 20 upon 50. 20 upon 50 is 2 upon 5 is zero point 0.4. So I can write it as same thing like this is equal to 0 0.4. Okay, for all x greater than or equal to 70. And what about the other values from 50 to 70? If you see, it is 0, right? 50 to 70, let us say 60. 60 minus 50, 10 upon 50, 1 upon 5 is 0.2. Minimum of 0.2 and zero point 0.4 is 0.2. So it will be and is equal to mu fast of x for all right, 50 less than or equal to x less than 60, less than 70, sorry. Okay. Okay. So this is about the clipping, which is nothing but the we are calculating the output membership function. And from this output membership functions, and we can calculate for all other speeds also like this. And when we calculate the aggregate uh, value, we will arrive at the uh, from this modified membership values at each speed, we next calculate the aggregate value. So we have something like aggregate value at that speed. You know what? Why this aggregate and what is this? Why is this different from this above modified value? Let us say if my speed is, let us say, 60. So if you can see from the graph of output membership function, it pertains to, I just share the graph of output. So this 60 is pertaining to medium as well as fast. So membership of medium and membership of fast, and then that's why we calculate the aggregate. So okay, so and aggregate is nothing but always maximum of those two inputs. Okay, so mu aggregate of x, this is how the system calculates at every value. Again, it is nothing but maximum of modified membership, in this case of medium, and max modified membership of fast. So out of these two values at that particular value of x, which one is the maximum, that will be considered under aggregate value, and all those aggregated values we use centroid method and find what is the value which is the centroid of all those aggregated values. So this is slightly more complex in maths if you are not able to follow. But if I just take it, for example, if let us say x equal to 70, so as per our just example I'm taking to make it clear. So mu medium of x at 70 is nothing but 75 minus 75 upon 25, which is 1 upon 5. 1 upon 5 is zero point 0.2. So minimum of zero point 0.2 and zero point 0.2, which is zero point 0.2. Okay. Okay. Minimum of zero point 0.2 and zero point 0.2, which is 40. So I'll write here mu dash of medium is zero point 0.2. And what about the fast? 70 minus 50, 20 upon 50. 20 upon 50 is 2 upon 5. 2 upon 5 is zero point 0.4, right? And minimum of zero point 0.4 and zero point 0.4 is zero point 0.4. So mu dash of fast is zero point 0.4. Out of these two maximum values of zero point 0.4. So aggregate value at 70, I can say is nothing but zero point 0.4. This is how we are understanding it. And that is what is even shown in the graph also. If I see the intersection region, let us say, okay, I just show that clipping region. So at 70, if you see, it's not zero point 0.2, but it is 0.4, maximum of the values, the shaded region. And by coincidence, that is the even centroid value in this case. Okay. So understand like that, right? Okay. Now all the aggregate values we'll find out. Okay, in a similar fashion, considering the medium and fast categories, and then we will calculate the centroid. Our system will calculate the centroid. We calculate mu aggregate of x at every value of x lying in the medium and what we can say the fast category. So all those values, let us say from 30 onwards we are starting, right, where the clipping is happening at point. From 30 onwards till 100, if we calculate all the membership values and the modified membership values and then the aggregate values, all the aggregate values if we note, and then we can find out the centroid. So the formula of the centroid is nothing but, so I'll write it as y star is equal to summation of the product of each individual value of x, which is the speed in this case, and aggregate value of x divided by summation of mu aggregate of xi. So let us say it is 30. So 30 into value at 30 divided by 30 into value at 30 plus 40 into value at 40 plus and so on and divided by and I'm now only taking 30, 40, 50. In fact, it is each point 30, 31, 32 like that. And similarly divided by, it will be membership at 30 plus membership 31, 32 like that is 100. So this is nothing but it's related to center of mass calculation, center of gravity calculation. For those of you who have had that concept in class 11 and class 12 physics, right? So weighted average will be calculated, and that is nothing but if you work out in this case, it is coming somewhere around 69.8. Intuitively also, if you can see the figure, we will can arrive at its approximate. If you see this graph also, okay, it consists of a trapezoid between 30 to 40 and the rectangle from 40 to 60, and then followed by another trapezoid. Okay, so if you see the each of the trapezoid and then mark the center point, you will, and then you can arrive at the final. So for example, for the first trapezoid between 30 to 40, if you find out the centroid center point, it will be coming around 37.5. And similarly for the rectangle between 50 to sorry, yeah, yeah, 50 to 70. Okay, we can also consider 40 to 60 rectangle, or 50 to 70. Okay, that rectangle, you can see the center by just point of intersection diagonals and where the x-axis is touching. And similarly for the rightmost figure. So you will, if you take those three figures, three values, it can come around closer to 38 for first figure, maybe 60 for second, maybe some other 85 like that. And if you can see the balance point by using the same centroid formula in that case also, you will be arriving at approximately somewhere close to 70 or 69. So that is what is the system also calculating. So I'll just run through the code now. Uh, so we have understood the question and the libraries. Then first we define the universe. For input temperature, it is 0 and 40. 0 is the lower limit, 40 is the upper limit, which is antecedent. Then consequent is the output value, which is 0 to 100 fan speed. Then membership functions we define what is cold, what is warm, what is hot uh, by using the fuzzy sets. Then for similarly output also we define the membership functions. And then just for our understanding, we have seen the plot using a triangular function. If you see the membership functions, we are using triangular functions. So definitely the plot will be triangular plots. And then we are defining the rules. If temperature is cold, fan speed should be slow, and so on. Then we build the control system, and we take the input temperature 28 and then simulate the uh, output, right? So first we simulate the input, and then we have the membership degrees like 0 for cold, 0.2 for warm, 0.4 for hot. This will be calculated here. That's the output. And then intersection for our clarity. So where it is intersecting the input membership functions. And this is the output triangular functions. And rule outputs, okay, it is clipped for slow 0, it is clipped for medium at 0.2, it's clipped for fast at 0.4. Okay, and then aggregate all the rule outputs, aggregated output we discussed, and from the aggregated outputs we calculate the centroid value. This is defuzzification, last step, and it comes out to 69.81. And we can also calculate aggregated output plus centroid using this code, and in this diagram we can get so 69.8 on the 70 is the centroid. Okay, now we can simulate the fan speed for various temperature values also. We'll get a somewhat a heat map we can convert it into, and so every temperature range, what are the values. So fan speed is going from slow to medium to fast. Now brief understanding, if we introduce one more variable called humidity and make the logic or rules slightly complex by using and or not conditions. Okay, the input variable temperature is having same range, humidity is now introduced between relative humidity 0% to 100%. Output is again fan speed in percentage. Now the rules we have framed as 9 rules, just made somewhat complex, okay, by introducing and condition. Okay, you can go through this. So again, we are building the same code. Only thing we are introducing humidity as another input. Okay, so there are three membership functions now, and then we are defining the fuzzy rules, whatever we have defined those 9 rules, build the control system, and compute fan speed for each temperature and humidity pair. So we have got this list if you see. Okay, and then we can also arrive at the 3D surface. The 3D surface, if you look at it, one axis is temperature, one axis is humidity, which are the inputs, and for those combination of inputs, what is the output? So this is called a 3D surface plot. So I am sharing this code with you. Explore it and try to revise the concept of fuzzy logic. All the best.